This is question 4 of the P1.5 end of topic test. On screen now is a mark scheme for the question, so please mark your work. If you get the question correct, please move on to the next question. If you get parts of the question incorrect, please listen to the rest of the recording to find out how to answer the question correctly in the future. Just one note I'll draw your attention to on the mark scheme is that this part here that I've just highlighted should read 1.5 times 10 to the 6. Okay? So you may wish to pause the recording now so you can mark your work. So in the first part of the question, it gives you the information that in the diagram below, A to B are two radio navigation beacons. They both transmit at 1.5 megahertz. Okay, we might as well highlight that now. 1.5 megahertz, well, it's measured in hertz, that's a frequency. That's 1.5 megahertz. Now remember that mega is basically the same as a million. So our F equals 1.5 million hertz. You can leave it as 1.5 million if you want to and work it out through there. Just remember to add a million on to the next bit, or you can basically say that that is 1.5 times 10 to the 6, or you could write it out as 1,500,000 hertz. There we are. So any of those is equivalent for the frequency. Now, actually, to calculate the wavelength of the radio waves, well, the speed of the radio waves is 3 times 10 to the 8, or 300 million. Now, you get the first mark from remembering the equation that V equals F times lambda. That, believe it or not, is 1 mark in the question. Okay, and remember that will be on the formula sheet at the front of your exam. The next bit is to substitute in the numbers. Okay, so we have 3 times 10 to the 8, and I'm just going to leave this in standard form. Multiply by 1.5 times 10 to the 6 times your wavelength. The next part of the mark scheme is for rearranging that equation. I'm just going to move up here. I'm going to work in blue, so I'm going to go up here to get that lambda equals V over F. But as we've already got in this format here, lambda equals 3 times 10 to the 8 over 1.5 times 10 to 6. That gives me the answer that lambda equals 200 meters, and that there is my answer. So in terms of the marks, you get 1 mark, remember, for this bit here, which V equals F times lambda. Second mark for putting it into the equation. The third mark for getting the right answer. Now, if you forgot to do this bit here, and just use 1.5, you would only lose 1 mark. You just lose this mark here, and you get an error carried forward mark there. And that should come out of an answer about 200,000, I think you would end up getting, which would have got you 2 marks out of the 3. In the next part of the question, it tells us to calculate the number of wavelengths which is equal to the distance between A and X. Looking at the diagram, A is here and X is down here, and that's the distance of 1,600 meters. Okay, and we want to know how many wavelengths we get in that distance. So what we're going to have there is our answer, which is going to be number of wavelengths, which is lambda, equals our 1,600 over our wavelength lambda from the previous question. Now, we worked out, I was writing in blue, that lambda was equal to 200 meters. Okay, but you get an error carried forward mark here, so whatever you wrote down on the last one, as long as you do 1,600 divided by that number, you'll still get it correct. But following it through with the correct answer, we get lambda equals 1,600 over our 200, which comes out to be 8 wavelengths. That would get us the final mark on this question.